In this video, we are going to talk about properties of sine and cosine, and then we're going to get to where we can talk about transformations of those functions. So with the sine function, and we saw this in the last section, domain is all real numbers. Okay, that's what kind of things we can substitute in, because remember, sine is defined to be the y value divided by the radius value when we have any kind of triangle. And everything that we're talking about is built around this unit circle, x squared plus y squared is equal to 1. And on the unit circle, the radius is 1. The range, we're only going to get out numbers between -1 and 1. We talked about the sine being an odd function here. So it has symmetry with respect to the origin. And we talked about how often it repeats itself, which is called the period. And we said the period was 2 pi. We can also find x-intercepts. Remember, an x-intercept happens when the y value is 0. And if we think about that unit circle, that y value is 0, here 0 and at pi. And then we could go around the circle again to get to 2 pi, 3 pi, and so on. If we wanted to go backwards around the circle, we would have 0, negative pi, negative 2 pi, and so on. So you can see it's all integer multiples of pi. So there's our y-intercept. Sorry, x-intercept. We could write it condensely as k pi, where k is an integer. And we use that funny e, that means element of, and that z means integer. So we're going to start seeing a lot of shorthand math notation in this course. The y-intercept's where it crosses the x-axis, and we know that the sine of 0 is 0. So that's why that's the y-intercept. And then we could talk about where we have maximums and we have minimums. So here's our sine graph. Maximums are happening here, minimums are happening here. So you can see how that pattern is going to repeat itself over and over and over again. Cosine function, really similar. Domain is all real numbers. The range is everything between -1 and 1. We said the cosine function has even symmetry, which means it's symmetric with respect to the y-axis. The period was still 2 pi. And if you think about x-intercepts happens when the y value is 0. So we're talking about this function here. If y is 0, we're asking where does that happen? And that's happening, if we look at our unit circle, erase everything we were doing for sine. That's happening here and here. The cosine is, remember, cosine's x value. Cosine 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. So the x-intercepts are happening at odd integer multiples, 2k plus 1, of pi over 2, where k is an integer. Okay, remember we talked in the last section how we could write 2k plus 1 to meet an odd number. So that is how we would condensely write that. The y-intercept happens when x is equal to 0. And if we were to plug in 0 here and think about our unit circle, the cosine of 0 is that x value of 1. So that's why you're getting a 1 for that. And then we could talk about minimums and maximums. Maximums are happening here. Minimums are happening here. So the question is, how do we go about doing some transformation stuff? And I like to do transformations pretty much the same way that I did them back in a pre-calc class, where we can talk about moving them horizontally. So that's left, right. And then we could stretch or shrink, and then reflection, and then up or down. So what we do is we start with the parent function and we build up to this new function that we're trying to find the transformation of. But before we do that, I want to look at sine and cosine a little bit more carefully because this is really neat. Okay, if we were to look at the sine function here and we were to look at the cosine function here, don't they look the same? Aren't they pretty similar to each other? And in fact, if we were to take this guy and we were to shift it to the left, then wouldn't these functions live on top of each other? So we can actually build a transformation from the sine function to the cosine function or vice versa. We could take this guy, we could take the cosine function, and if we were to shift this to the right, pi over 2 units, then we would end up with the sine function. Cosine shifted to the right, pi over 2 units. And we show we're shifting to the right pi over 2 by changing that theta here to theta minus pi over 2. Remember, that works the opposite of the way you think it would. That shifts us to the right. So we can get from one to the other by looking at those transformations. So that's kind of a neat thing to think about. Next thing, before we start graphing transformations, I actually want to look at something called amplitude and something called period. Now we know for the basic function, these are our parent functions, right? Sine of theta and cosine theta, or we could say sine x, cosine x. We know that those both have a period of 2 pi. Okay. Period is how often it repeats itself. But if we were to have a transformation in here where we have this funny w, which is called omega times x, then that's going to change that period. And remember what multiplying by this does is it affects the x's by a factor of 1 over omega. So then the period's going to change. Instead of just being 2 pi, it's going to be 2 pi times 1 over omega, which is 2 pi over omega. Now, amplitude is height. And when we talk about the height of a sine function or a cosine function, a lot of people think about the height from here to here. Okay, but it's not that total height. The height is really from that midpoint here. How tall is it here? When we talk about amplitude, that's what we're talking about. The height from the middle. We can think about it from the middle to the maximum or the middle to that minimum down here. That's amplitude. And the amplitude is, because we're talking about height, has to be it has to be a positive. So that's why we're using absolute value. And it's going to be whatever that number is in front. So for the sine function, the amplitude is 1, and for cosine it's 1 also. Okay, because that number that's in front of that sine and that cosine is understood to be a 1. And the reason it's 1 is because that distance from that middle to that maximum is going to have a height of 1. So let's just analyze a few of these. Let's find period and let's find amplitude. So for number 11, if we want to look at amplitude is going to be the absolute value of A, which is the absolute value of 2, which is 2. Period is 2 pi divided by omega. Now, this one doesn't have x multiplied by something, right? So it's kind of understood to be a 1 there. So then our omega is 1, so 2 pi divided by 1 is just 2 pi. And let's do another one. Let's do 16. Amplitude would be the absolute value of -3, which is going to be 3. And period is going to be 2 pi divided by omega. So our period is going to be 2 pi over 3. So with that one, this thing has a vertical stretch of 3. That's what the amplitude's telling you. Okay, notice we also have a reflection here over the x-axis. And then our period is 2 pi. So our period, this thing's happening more frequently than what the regular cosine function would do. And let's do one more. Let's look at 56. So 56 amplitude would be the absolute value of 9/5, which is just 9/5. Okay, so that's that height. Period is 2 pi divided by omega. So we're going to have 2 pi divided by -3 pi over 2. So 2 pi times we're going to get -4 over 3. And we don't think about period in terms of a negative. We're going to think about that in terms of a positive. Okay, because remember, it's how frequently it's repeating itself. It's repeating itself, in this case, every 4/3 of a unit. All right, so let's look at two more. Let's look at 60 and 61. They're asking us to build a sine function with these characteristics. So remember what this is going to look like. So they're telling us the amplitude is 2. Remember, that's that height from that middle to the maximum or that middle to the minimum. And they're telling us that the period is 2 pi divided by omega. Now, a lot of textbooks will use T for period instead of a P for period. To me, it doesn't matter which one you do. I'll use T just to be a little more consistent with our textbook there. So period, 4 pi, is equal to 2 pi divided by omega. We've got to figure out what omega is. So we're going to multiply both sides by omega, and then we're going to divide by 4 pi. So omega is going to be 2 pi over 4 pi, which is a half. So let's put everything into our format here. We have y is equal to whatever our amplitude is. Now, remember that A could have been a positive or a negative. We don't really know. We don't have enough information to figure out if there's a reflection. So I'm just going to put plus or minus there. And then our omega is 1/2. So there's the function that would have that criteria met. Okay, let's do one more. And you may want to pause the video, try it, and then come back. So here we know amplitude is 3. We've got to figure out what's going on with that period. So to figure out omega, we're setting up this little equation. And then it looks like omega is going to be, omega is going to be pi. Which we divide everything by 2. So here's our format. Once again, we don't know if A was positive or negative. We don't know anything about reflection, so I'm going to account for both by putting both in. So there is our equation that fits all of that criteria.